Greetings and welcome to the Plsql Challenge, a series of video trainings on the Oracle Plsql language. My name is Stephen Feuerstein and I'm a Plsql developer just like you. This lesson is part of my series on Oracle error management in Oracle Plsql, and the focus of this lesson is continuing past exceptions with a focus on FORALL and save exceptions. Quick reminder or two. Download all the code that I demonstrated and run in my presentations, and also the supporting PowerPoint documents from Plsql Obsession, which is located at toadworld.com/sf. Take a quick look. Click here to download the demo zip file that contains about 2,000 scripts that you can use to build your own applications and just look at different areas of Plsql. Training seminars and presentations provide access to all of my PowerPoints, and there's lots of other stuff that you can do and see and download from Plsql Obsession. In addition, make sure you're comfortable with the material covered in the previous lessons in the series, such as basic concepts of error management, defining, raising, and handling exceptions. And then, let's proceed. So FORALL with save exceptions, the agenda. First, I'm going to do a very quick overview of the FORALL statement for those of you who might not be intimately familiar with it. Then I'm going to drill down and to talk about how FORALL and DML errors, or errors in DML statements like updates, inserts, and deletes, interact with the FORALL statement. We'll look at the impact of adding save exceptions to a FORALL statement. We'll talk about working with the SQL% bulk exceptions pseudo collection. And that'll give you a very thorough grounding in how you can use FORALL and also suppress exceptions and allow it to continue past an exception that occurs in your statement. So, a quick overview of FORALL. The FORALL statement, which was added in Oracle 8i, it's been around a very long time, offers the ability to bulk process DML statements. Here you see a FORALL statement. It's basically, it looks like a for loop header on top of the DML statement. So for all the indices in some range of values, I then provide a DML statement. And somewhere inside my DML statement, I reference an array structure, a collection. In this case, a list of numbers. And I also reference that array, the iterator from the FORALL header as the index value in my array. And basically, after I do that, after I construct this kind of statement, when executed, Oracle will batch up all the DML statements generated based on the number of elements in this list of employees or whatever your array is, and then passes them over to the SQL engine in one context switch, resulting in pretty amazing improvements in performance. Now, this statement is very important to the FORALL statement, and you're going to want to use it wherever possible and also understand it very, very thoroughly. And it's covered in depth in the turbocharged Plsql execution with bulk processing lesson. So not a part of this series, but you definitely want to check it out. In this lesson, what I'm going to be focusing on is the exception handling aspects of FORALL, in particular, that of the save exceptions clause. But before I do that, just to incent you to learn more about FORALL, let's take a look at the FORALL timing script. Again, this is one of the files that will be in my demo zip, so you can run the script yourself, and a lot of these scripts are designed specifically so that you can verify the claims that I make in my talks. So, and I'm not going to run this now, but I'll show you what I built here, and I'll show you the results that I saw. Basically, I've got the parts table with part number and part name. And I want to compare different ways of inserting data into this table. So I'm going to populate some collections with a whole bunch of data. And collections are array structures, lists of information. And then I'm going to do row by row inserts. So for all the elements of my collection, I think I've got 10,000. Do a row by row insert into the table one at a time. And as an alternative to that, I'm going to do a FORALL insert, which is very similar in structure, but in this case, my insert statement is under the FORALL header and not inside a for loop. So that's the only change I'm making here. And by making that one change, I see some amazing changes in performance or benefits in performance. So running on Oracle 11.1, doing the for loop, the row by row inserts for 100,000 rows took almost 4 seconds. And that's pretty good for 100,000 rows. If you're not on Oracle 11, say on Oracle 10, you'll probably see this running in about 10 seconds depending on your computer. So simply upgrading to Oracle 11, you can see some significant improvements in performance. But the point I want to make here is compare the row by row inserts with the FORALL insert of 100,000 rows. 0.09 seconds from 4 seconds. It's nothing short of incredible. All I did was change the way I wrote my Plsql code to execute my DML statements. So please, if you're not already using FORALL, check it out and start using it wherever possible, wherever appropriate. Now let's talk about FORALL and errors. Because the idea behind FORALL, to go back to this example, is that you're executing DML statements, inserts, updates, deletes, merges. And as I'm sure you know, there are lots of errors that can occur when you're executing DML statements. Values can be too large for columns, you can get foreign constraint value errors, bound index, and so on. And FORALL statements are designed to execute multiple DML statements, 5, 10, maybe thousands of individual DML statements. But the default behavior is that if any one of these DML statements raises an error, what will happen is that that statement is rolled back. So the impact of that single DML statement is rolled back, and the FORALL statement stops as a whole. So if I was going to execute 1,000 DML statements, 1,000 updates, and I got to the third update statement, and that one had an error, by default, FORALL stops with that statement. The previous 2 updates that successfully completed are still waiting to be rolled back or committed. They are not automatically rolled back just because the third statement raised an error. However, the next 9,000, 10,000 DML statements will never be run at all. So that's the default behavior, and that might be perfectly fine. In other words, you're going to execute 10,000 update statements, but if any one of them fail, you just want to stop the whole thing. Perfectly legitimate workflow. However, since FORALL is largely designed for use as a kind of batch execution of DML statements, it's often the case that the developer will want to continue processing the rest of the DML statements. In other words, even if an error occurs on the third statement, the 15th statement, the 1000th statement, keep on going. Get through all the statements you possibly can. Then, tell me what went wrong. And that is actually possible with the FORALL statement using the save exceptions clause. So save exceptions in FORALL. This is exactly the same code I showed you before as an initial look at FORALL, but now what I've done is add the save exceptions clause. And what that does is tell Oracle to save exception information. So let's say that I have 1,000 elements in my list of employees. I'm doing 1,000 updates. And let's say that 5 of those updates fail along the way. Now, with save exceptions in place, Oracle will keep on going. It will not raise an error for any of those exceptions. And then when it's done processing all of the statements, it will raise a single generic exception, basically saying something went wrong in my FORALL statement. And then you can track that exception, and you can check the contents of a new SQL% attribute called SQL% bulk exceptions, which happens to be another kind of collection or array of information. And that collection holds most of the information you need to find out what went wrong and hopefully recover from it, or simply log the errors. So that's the basic idea. Save exception says, save the error information, keep on going, and when you're done, let's take a look at what went wrong. Let's take a look at an example. So add save exceptions to enable FORALL to suppress errors at the statement level. So each individual statement that failed is recorded as an error, and then we continue on. So in this case, first of all, note I declare my own exception, and I pragma exception in it so that this error is associated with -24381. -24381 is the error that Oracle raises, or the error code that Oracle raises from the SQL engine when at least one error has occurred in all the DML statements that are being executed. So that's the generic error code. Unfortunately, Oracle doesn't give it a name. So you should give it a name, and then add save exceptions to the FORALL statement. And then in your exceptions section, look for or trap the bulk errors exception. And this is much better to do than if SQL code equals -24381. So by name, I check for that exception. And then what I can do is iterate through the contents of the SQL% bulk exceptions pseudo collection. It's called a pseudo collection because it doesn't have all the properties of a collection. I'll get into a bit more detail on that later. But it's a collection of records. And there are 2 elements or 2 fields in the record, error index and error code. The error index points back to the index in that array in which the error occurred. The error code gives me the error code that occurred when that statement failed. So those are the core pieces that you need to put together to make save exceptions work. Let's run an example and look in more detail at the kind of information you get out of bulk exceptions. So I'm going to declare a nested table of strings. Now, if you're not familiar with nested tables and collections in general, it's extremely important that this become a part of your daily diet for Plsql development. So get a hold of one of my books or come over to training seminars and presentations, download Best of Oracle Plsql, or even better, Hands-on Collections, which is a 2-day training, including problems and solutions that you can use to spiff up your knowledge about Plsql collections. So I'm going to assume you have at least a working knowledge of that right now. But anyway, this is a list of strings. And I'm going to put into that list of strings 6 values: A, B, C, D, E, F, a really big 1,000 length string, little, another really big 3,000 length string, and then sniffer. And what I'm going to do is update now in my FORALL statement for every one of my filters, every one of my names. I'm going to update the employees table setting everybody's first name to the same name over and over again. This is a really dumb example. But the main point to be aware of here is that the maximum size for the employee's first name column is 20 characters. So these two are okay. This one's okay. And this one's okay. But this one is not. And this one is not. Now let's try running this without save exceptions first. I've got one others at the bottom that says show me how many rows were updated by the FORALL statement. And show me the format error stack, what went wrong. And when I run this code, I see the following. I updated 214 rows, and then I got the 12899 error, value too large for column. And there's the column. I got the problem. So let's take a look at what happened with that 214 rows. Okay, it executed one update for ABC, and it worked. And in fact, the employees table has 107 rows in it. So that's 107 rows updated. Then it tried to update for DEF. Hey, that worked too. So now we've got 214 rows. Then it tried to update for this one, and it said, no way, that doesn't fit. And it stopped. So it raised an exception. The FORALL statement stopped. The block terminated as a whole. I trapped the exception, and then I displayed the information. But, most importantly, these 3 rows in my collection were never used to drive the update statement. Now, that might be exactly what you want, and that's perfectly fine. But if you did want to do as many updates as possible, you need to add save exceptions. Let's take a look at what happened now. I run this code again with that one change. Let's look at the output. And now it looks quite different. Instead of updated 214 rows, I updated 428 rows. Let's take a look at why that might be. Well, pretty clearly, I did 1, 2, 3, 4 updates successfully. 4 times 107, 428. And then, let's read what happened after that. The first error occurred on index position 3. Let's see, 3. There's 3. Attempting to update the name to this really long string. And the error is Oracle negative 12899, same error as before. And then the second error occurred on index position 5. Yep, there's 5. Trying to update the name to an even longer string. That didn't work either. So we get the negative 12899 error again, value too large for column. So I was able to keep on going and update for 4 of the different input values, so 4 different updates executed. And I was able to grab information about the problem that occurred for those other 2 indexes. Pretty good stuff. Let's take a look at that exception section. So I'm going to trap for an error. This is the negative 24381. And in this case, I've got a separate package in which I have to find my failure in FORALL error. So when I trap that exception, I display the error stack, which shows me the specific error, which is, this is the negative 24381. Notice it's very generic, errors in array DML. No information there, just something went wrong. Then the total number of rows updated, 428. Okay, then Oracle has populated the SQL% bulk exceptions pseudo collection. It's like a regular collection of records, but it doesn't have all the methods built on it. You can go from 1 to count, but you can't, for example, go from first to last. So I go from 1 to count, show me all the errors. And for each one of the index values, define and SQL% bulk exceptions, I have two fields, error index and error code. So this DBMS output line says, well, show me the error message associated with that error code. And I show me, first of all, the index on which it occurred. So that's the error index. That points back to 3 and 5. And then show me the name that I was trying to update it to. So I have access to all of that information. Any information that's in that binding array that drove the update statements, drove the FORALL statement, can be accessed through that error index. And then I have the error code. And I can call the SQL error message function, which I talked about in the previous lesson on handling exceptions. I can pass the error code to this function to get the generic error message. But notice it's kind of odd. I have to multiply it by -1, because even though SQL error message considers the error codes to be negative, the error code coming out of SQL% bulk exceptions is a positive number. Strange stuff. So that gives me all that information. And in general, that's what you want to do with SQL% bulk exceptions. Iterate through it, and you can display information. Much more likely you're going to log the error information. You'll log it in some way or other. You might even have code like, if the error code is a certain number. For example, if the error code is equal to 12899, then I want to try to do something, try to recover. So you can have some very granular work going on here to try to finesse the errors that occurred, or you might simply just log them up and you're done with it. So very, very nice feature. It's one of those features that Oracle got almost completely right. There's one problem that I can see. Let's go back to the output. When I didn't have save exceptions, and the statement failed after the first DML update that failed, notice the information. It tells me the location or the column in which the error occurred, and it also gives me the maximum, it also shows me the actual size, the 1000, and the maximum 20. So there's a lot of information in that error message. However, when I display the error message for the save exceptions version, notice all the specific information is gone. There's no column information, and there's no size information. And that's because Oracle made a mistake. They saved the error code when they should have saved the error message. Once I have the error code, and only the error code, I can look up the generic error message, but I've lost all the specificity. So hopefully in a future version of Oracle, they will add a third field, error message, and give us more information. It's really pretty critical, and we've talked, several people have reported this issue to the Plsql team. Hopefully they will listen to us and add it in Oracle 12. We'll just have to wait and see. So to go over some of these details, for each exception that's raised, Oracle populates the SQL% bulk exception pseudo collection of records. Two fields, error index, pointing back into the binding array in which the error occurred, and error code, the number, which is positive for the error that was raised. It's a pseudo collection. It doesn't support all the methods, but it gives you what you need to iterate through those rows and process the errors. And as I mentioned, it does not store the error message. So it's a very powerful feature. FORALL is incredibly powerful. Save exceptions makes it very practical in a lot of ways to use for very large batch processing. You just have a slight lack of information when it comes to actually understanding what went wrong when that error occurred. Hopefully it will be fixed. Conclusions. The FORALL statement is one of the most important performance enhancement features of Plsql. I would label it as the most important feature enhancement in Plsql since Oracle 8i. And you should look for every opportunity to use it. Basically, look for any loops that have DML statements inside of them. And if you're going to use FORALL, then you need to decide, what should I do? What needs to happen when one of those statements raises an error? If you want to execute all of the statements regardless of any errors that occur, then add the save exceptions clause, and in the exception section, trap for that -24381 by name, and check the contents of that pseudo collection to see what kind of errors occurred, log those errors out, and so on. My apologies for that typo right there. It should be XC. So powerful feature. Make sure to decide if you want to use save exceptions. Another option that we're going to explore in the very next lesson is as an alternative to save exceptions, you might consider using the log errors clause. So check that out. Next steps. Download that demo zip file. Grab the scripts that I showed you in this lesson run them, study them, make sure you understand exactly what they're talking about, and get comfortable with using FORALL on every possible opportunity. Then watch the next webinar in the series on DBMS error log and log errors, which allows you to continue past exceptions, but in a different way. You're actually suppressing errors inside the DML statement at the row level. Very interesting feature, very powerful, and also there are a number of things you need to be aware of before you start using them in your production code. So I hope you enjoyed this lesson and enjoy the rest of them. Happy Plsql coding.